it's essentially trying to image underground what's really happening, because right now we don't know all that we need to know about that, and that costs money. And so a kind of a two-part fundraising process, but $100 million. And again, we know very clearly that there are large groups of people quite interested in this process internationally, because, as you can well imagine, investors want to make money at things. The challenge the company presents is to show them that what is here in Ireland is worth investing in. And if we can show them that, then they will be quite keen to come and invest in it.
Could I ask you, have you ever been into the Arigna mine?
No, I haven't.
The ground around there is already fracked. They never had an explosion in Arigna. Now, I grew up in Yorkshire, and the sirens used to go and the town would be at one because somebody was dead or somebody was injured, whatever. It never happened here. In all the time that place was mined, and if you look at the geology there, it's fracked. It's naturally fracked. So I doubt there's any gas down in that area at all that hasn't already come up.
The young lady here certainly raises a very good point. Well, she raises a very good point, because we won't know until we drill that well, to be quite honest. Now, some of you don't want us to get to drilling that well, and I respect your opinions, but we really won't know exactly what you're saying until we do. And that is a very possible result. One of the benefits of working shallow, less than a kilometer or so, is that it's cheaper to drill. One of the risks of drilling shallow is that it's too close to surface and the gas could have escaped sometime in the past.
Yeah.
What about the radon? What about the radon?
You're absolutely right, sir.
Big waste of money.
It's a big risk.
It's a big waste of money.
The radon, I do wish to address. That's a very good point, and this gentleman has really been quite patient. Our initial study of the drill chippings that the prior operators did, there's been 13 wells drilled in the basin, encountered no mobile radioactive elements in that formation that we are targeting, called the Bundoran Shale. I do know that you will have seen some talk about radioactive elements in shale, but I would like to add to that that actually only occurs in about 1/20th, 5% of the Marcellus Shale in the United States on the East Coast. All of the other, what we call thermogenic or deep shales, have not had a radioactivity problem. We don't anticipate it here based on the analysis. If we saw it, I can assure you that that is not a program I want to proceed with. There are no treatment facilities for such radioactives, as you know. It would not be a viable project. Now, our initial analysis says that won't happen. Once we put the $100 million in the ground, we'll know better. If we encounter that, those wells will end up sealed, and that's unfortunately for us where it would end. So,
yeah, who defines what a chemical is? Is it your definition of a chemical? Because at the end of the day, it's not so much the question of whether there is a chemical. The question is, will there be pollution? Will there be pollution? Like, for example, salt is, we all eat salt every day, but
yes,
you know, take salt in a different context, then it's a pollutant.
Right on.
So the bigger question is, will there be pollution?
Right. Let me get to your first point. I'm happy to define a chemical, and I'm sure there are expert definitions, but mine is, if you can't bake it into bread and eat it, it's a chemical. If it's not safe for you to consume, it's a chemical. If it has the ability to interfere with the chemistry of the environment around it, I'm going to go on like this, then it's a chemical. It needs to be inert. Water is inert in that respect. It won't react. But you raised a very good point about salt. The United States learned a very hard lesson in the 1960s when it allowed operators to produce recovered water back onto the ground. It's only water, right? It came back with all the salt, because what water will react with is salt. And we know salt water will kill everything, as you see in Gasland when they drive around showing what salt water dumped on New Orleans did. It killed everything. I lived there for a year after the storm. And so to your exact point, we cannot allow salt water or the recovered water in any way to touch the ground or the atmosphere. Our well pad design does two things in that respect. First of all recovered water is put into tanks, and then it goes through a cleaning facility, or we'll simply reuse it in the subsequent frac. But if it goes through our cleaning facility, then it will be drinkable, it will be water worthy. And secondly,
Will you take a sip?
I will happily take a sip of it. Actually, sir, it's a very good question. It's an absolutely fair question. We'll be drinking water right from the edges of our lease. I'm going to insist on that because no better way to make sure it's safe, is there? But to the point, the second point on not just the salt water, when water comes back from underground, it will, no matter what you do, contain a little bit of the very gas, right?
Yeah, it's full of shite, as we say here. It's full of everything. Anything you can imagine.
Anything that could leach
and you
back.
were talking in your presentation, and I've seen it online, the presentation to your shareholders, you're talking about 2,000 meters down, and you call that shallow fracking. To me, 2,000 meters is 2 kilometers, and I wouldn't walk that distance, to be honest.
Me either.
Yes,
I'm
can
kinda
I
lazy that
just...
We actually can't drill deeper than 1,500 meters in Ireland, so I'm not sure where the 2 could be coming from. Maybe that's somewhere in Australia. There are projects we have that are that deep there. In Ireland, they won't go
Will
deep
there be
enough.
pollution?
Well, sorry, yes,
That's the
to
question.
catch you back on
Yeah,
it.
will there be pollution?
At the top of all these tanks, they're conical, and so what that does, it forces any emissions that come out of that water to be captured at the peak. And what you would see is a series of pipes that come out of all of those water tanks, and they go to what's called a vapor recovery unit. Think of it as a little compressor, like an air compressor, but it basically sucks the gas volumes off. And then those are stored in tanks. And of course, if we had at some point in the future when the gas is being sold, then those can be moved down the line. But in the meantime, they'll simply be gathered and compressed so that they don't get released. You raise very good points that you cannot allow things to escape. So I prefer the words closed system. Everything on the lease is a closed system. Nothing is allowed to come in or out without being contained somewhere.
What happens to the pollution that comes out of the ground if you're extracting from the water? If you're purifying the water, there must be some kind of sludge or mud.
No, you raise a very
Where
good
does that
point.
go?
It's a critical point, and we have to address it on a local level, so it's a very good question. The fact is, take the salt even, that will accumulate in the treated water, for example. Some solids may come back with the water simply because they'll carry back particles. All kinds of things could be in theory. Minerals, irons, for example, right, could come back as we break the rock down. Those solid materials are going to have to be gathered. We're going to have to find a solution for those. Now, right now, the mining industry uses its own tailing ponds, and then it has its own disposal
So there is no
arrangements.
solution at the minute that you're looking at.
I want to be completely honest with you folks in that respect. Our design has not reached that stage. I know that the mining industry does dispose of much worse things than we will get back, and we will have to adopt their techniques, but I don't want to pretend to you that I know what they are. I have to go with what the EPA rules to us that we do, and I'm no expert on that side. You raise a very important question because not the least of which is when that material is taken from the site, it has to be transported. That has to be done with the utmost of safety.
So you say that we talk about containment, but you're talking about the pollution being contained under the ground. So that means our water table will be polluted.
The water table cannot be polluted as long
As
as,
long as, yeah.
absolutely right.
If some buts.
Well, they're big ifs and they're big buts, but the point is they've got to be done. Fair enough, sir.
The problem is,
no,
the
that's
problem,
waffle.
I think the problem is that there's always people like you when these projects come in with good talks and promises and everything. And then we see in places like Bhopal in India where then, you know, when the realization that there's problems with pollution, nobody's there. The company isn't there anymore. The shareholders are not there. And you have another job. And you see the safety, it's just words that you have. And then it's our land and it's the safety of our water and our.
And once it's polluted, it's too late.
You see, there's very safe energy which doesn't destroy the earth. And
for our generation,
Yeah.
the next generation.
we have to think of that. It's just, you know, promises or thinking we might try or whatever. We have to see and this. There's no safe. I don't know of an example of somebody who's come in and decided this kind of brilliant thing and that it's safe. Everywhere in the world we have pollution, we have destroyed land, we have destroyed livelihoods, we have death, we have cancers because of these kind of things. And so your promises, I'm sure you do your job very well, but you know, it's not enough for us.
Very well said, and the Bhopal disaster is by no means, yes,
And it's
exactly.
still going on, it's still going on.
Absolutely, the companies never took responsibility.